Hello, everybody, and welcome to today's session. It is the introduction and overview session of the certificate programs in Python for algorithmic trading and computational finance. I'm Eve. I'm founder and managing partner of the Python Quants as well as of the AI Machine, and I'm your program director. Today's session is intended to give you a broad overview, and we will also go into a few case studies and demos so that you get kind of like a better feel and a look at what details to expect, what topics will be covered, and how does it look when you go through the resources. And there is a wealth of resources that is planned for over the course of the 12-week formal program. We then have the 4-week practical phase afterwards. And given that we have that much to cover, I want to dive into the slide deck and want to get started here with the agenda. A quick look at the agenda. I will spend 2-3 minutes on introduction about us, what we do, what I've done, then the program and a broad overview, and then we go through the single classes like Finance with Python, Tools and Skills, Python for Financial Data Science, Python for Excel, for databases, AI and finance, then the core classes, Python for algorithmic trading and Python for computational finance. I will then walk you through the study plan. We'll then have this core part of today's session, which is called case studies and demos. I will then spend towards the end a few minutes on the user forum and topic of my heart, the importance of practice. And it's for the first time, and I'm really excited about that part, that we run the two certificate programs in parallel. And I have decided to do so since the majority of delegates has decided actually to do both core classes. This does not mean that you need to do them necessarily at once. There are alternatives to the example study plan. I will comment on that when we get to the study plan. But let me get started with a quick introduction. The Python Quants, the name says it, we are concerned with Python and other open source technologies related to the financial domain, in particular quantitative finance. We provide trainings, online trainings, offline, on-site trainings. We run a platform, the Python Quant platform, to which you all have access, which has more than 20,000 users. We have open sourced a bunch of packages. The biggest one, the largest one, is the DX Analytics package. I've written a few books on the topic. You will see them in a minute. And we provide the certification, basically based on our certificate programs in cooperation with the university. And we run a couple of events. I just returned from a US trip where, for example, we organized in cooperation with one of our strategic partners a bigger event in New York City in Manhattan. More details you find on our page, tpq.io. Feel free to explore the resources. I talked about the Quant platform that we run. Here you see the overview. Basically, it's an integrated interactive financial and data analytics environment. You can execute codes there, you can develop codes, you can share codes, you can test it, you can work basically autonomously in the browser without having even a local Python install, for example. And for example, also go through the resources of the program. Not all of them, some of them are targeted towards local deployment or cloud deployment, but most of them can be executed here on the Quant platform. One of my demos and overviews will be related to the Quant platform and how to navigate there. Then our current major project, the AI Machine, which is about the standardized deployment of AI-powered algorithmic trading strategies. We have a team there in India which takes care of the development. We are already in a phase where we do live testing and now plan to scale and build the whole story out. This is mostly related to algo trading, and it's a natural outgrowth from my point of view of what we have been doing over the last few years. And I like to say this is now our walk the talk project, where we try to implement what we preach actually in practice in a scalable, standardized fashion. Yeah, if you want to get A quick overview of what we have been doing and with regard to the certificate program. There's this link, and this leads you to the one-pager. So it's maybe a 2 or 3 minute read, so that you get everything written there as well, or you might want to share this, for example, with others. I think it's a good summary here, this article from Capital Market CIO Outlook. If you haven't seen myself, this is myself in action giving a talk. This one was in London a little while ago. You see also the link to my private page, and private means here that I collect my talks, my personal talks, and my workshop resources, and quite a bunch of other things like links to podcasts or links to YouTube videos there. So it's basically also a Python for Finance page if you like. Feel free to explore the resources there as well. Most of them are related to what is important for the core topics in our certificate programs as well. Yeah, here are the books. The middle one just came out, Python for Finance, as a second edition last December. I think it's a major upgrade, not only an update. It's also selling quite well, and I'm not saying this from a financial perspective, but rather since I'm so happy that our topic is now so commonplace and widespread. It's not only that the leading hedge funds doing bleeding edge data analytics apply Python for finance and for trading. It's rather something that is now used at universities around the world. I know here from a few in Germany, but also in Asia, and in particular in the US, where the book is used at university. And this is what makes me a little bit proud. So when I got started with the topic, this was something, oh, well, are you sure to use Python for finance? I said, yes, I'm convinced here. And this was more like a sales pitch. And I'm not saying that I'm the one who brought it that far, but I'm happy that the topic itself has come that far. For the computational finance part, of course, the blue one will be at the core, derivative analytics with Python. It's more like a practical application of what is shown here in the Python for finance one. And this is then, I guess, the orange one, listed volatility and variance derivatives, more for those who are interested in this specific field. I just started, signed the contract a while ago, and just started writing AI in Finance, Artificial Intelligence in Finance, a Python-based guide. So that's the new book project. And I got a good start recently, so according to plan. And my plan is to have the first manuscript towards the end of the year. But somehow I have the feeling that's a little bit ambitious, but I like to have ambitious goals in this regard. So watch out to see some early drafts, maybe sometime soon there. These are the 3 books, the 4th in the making. If you're interested in joining communities, so I've just picked out the 2 meetups that I'm currently organizing and running in the 2 major capital cities, because I know from our data, our population, that most of our delegates are from these areas. There is the Python for Quant Finance meetup that I'm running since quite a few years already. We have 2,800 members as of today, have done a bunch of bigger meetups, smaller ones, different formats there. So feel free to join if you are in or around London. In New York, we just started this new one about AI in finance and algorithmic trading. We had our first event short while ago, and we had already more than 100 people in attendance. It's of course a topic that is of interest in our domain, and even if you are not maybe in one of the capitals there, you might join the group, so you might benefit of resources that are posted there, keep up with what is going on. So feel free to join the group, either if you are interested in joining a local meetup or in just following along what is happening and getting access to slide decks, and maybe even sometimes to recordings there in this regard. In the meantime, there's an interesting question, and I think it fits pretty well into the introduction part. It's why Python is taking off for algo trading rather than, say, C#. I would not focus here on C# versus Python. I would rather say Python versus the rest of the world. And I think, first of all, we have the scientific and the data analytics stack, which makes so many tasks that we face in finance and algo trading so much more efficient that many people thought from the beginning, well, we save lots of time here, and we might even overcome the bottleneck of maybe, let's say, some performance burdens that we might face in the Python ecosystem. I think all those people have thrown right. I used to say that when you looked around for the bigger financial institutions like the banks on the sell side, they used usually something completely different back in the days, a couple of years ago. The hedge funds were the first, and I always said, well, have a look where the principals run the shop. This is where Python is used. So when big budgets might be something that the owner needs to bear, then people use Python for efficiency reasons and maybe for like personal conviction reasons in that sense. But I think given the adoption and the quick adoption, so many things have evolved and the ecosystem has grown so rapidly and with regard to the capabilities that these days, I think there is no way around it. With many other languages, not focusing on a single one, you typically don't get the full package with regard to what Python has to offer. And I think even when it comes to performance, the usual criticism that is raised with regard to Python being slow, etc. I think we've overcome all these burdens. So even in the AI field, this is one of the major reasons I note or cite today is Python is a first-class citizen. So if you want to do AI or machine learning, Python is the way to go. And since we are doing that much machine learning, deep learning, etc. in finance these days, I think this is one more reason why we should go with Python. Here you see our partners. I like to mention them because many things that we do, like the meetup in New York that I mentioned, which was sponsored by Refinitiv, wouldn't be possible without strategic partners that are, in general, much, much bigger than we are. We also run for Python Quants Bootcamp coming up together with Fitch Learning, CQF Institute, and the certificate itself, so that we are able to have an accredited program which leads to a university certificate. It's only possible due to our partner here in Germany, the HDWSR, University of Applied Science. So I'm pretty happy and feel myself privileged that we are in a position to work with such large and powerful partners and renowned partners in order to provide what we do there. Yeah, that much with regard to the introduction. I think you now should have a good feel for what we do, where we are coming from, who we are working with, and what we do with regard to community. Feel free to explore our web pages and to maybe read even more, or to reach out by email and ask for hints, links to additional resources. Now, with regard to the program, yeah, it has grown. It has grown. So here it's the slide that I typically use for the certificate in Python for algorithmic trading. I said already, the majority of delegates have opted for the combination we call Platinum package, which makes me really happy because this shows the interest is like a little bit broader than maybe just for one specific area. Python, this was a question from before, is used in every corner, in every area of our financial ecosystem. And for algo trading alone, you see the numbers. When we have an overall look, we have 1,000+ pages of documentation. We have the finance with Python documentation, the Python for finance documentation. We have the algorithmic trading documentation for the course, class, and program, which is alone 500 pages roughly with lots of code. Then the derivatives analytics one, we have 10,000+ lines of code that we provide, the combination of the programs, more than 200+ hours of pre-recorded video instruction, a bunch of Jupyter notebooks. I myself am not sure, I never counted them, so I stopped counting beyond 50. So maybe there are 100+ Jupyter notebooks, count ones. And of course, we add to the mix as we go. So we always update, we add, we refresh, we even come up with new topics. So I will talk about it in a minute. The AI and finance class, which is so to say brand new from the last cohort, which we did from scratch as a 12 session series, which is exclusively concerned with the role of AI in finance, exploring some stuff which has been explored before, some things that I comment on and where I see kind of the huge potential. So that's actually what the program is made of. Lots of material. I think it might look from the outside a little bit overwhelming even, because there might be some technologies that are new, let's say cloud deployment for some, or machine learning for others, or maybe even some areas and parts of the finance base. But don't be afraid. I mean, we will repeat things over and over in parts. We'll have different angles by which you can attack the topics, and maybe not everything from the 100% we offer is completely important for what you are striving for. So it's a menu of options, and when you enter a restaurant, I think you're not expected to eat everything that's on the menu, but I'm pretty sure you find the elements, you find the skills, you find the components that will help you with your personal requirements, your corporate professional requirements, or with your goals that you have in mind. So see this more as an offer from the outset. And even if you take maybe longer than the structured 12 weeks, this is not a problem at all. You all have indefinite access to the resources. So let me get started with the classes themselves. So finance with Python is a starting point for everybody for the two programs, and therefore also for the mix, for the Platinum package, the combination of the two certificate programs. So this is what we have designed as a gentle introduction to finance, Python, and a combination of both. So we have had quite a few people over the years who said, well, Eve, I'm a seasoned data scientist already, but I'm pretty new to finance and want to enter the field. Do you got something for me? Or other people say, well, I've been trading for 10 plus years and now want to automate things. I know the finance side, but I'm lacking maybe a formal programming education. So with the two of them in mind, and as a third group, those who said, well, I simply want to get a gentle start so that I'm sure that I have the same foundations as everybody else, we have designed finance with Python. So we get started with basic finance theory and introduce alongside the basic finance theory the math that is associated with it, and at the same time Python on a very gentle and fundamental level, so that we say, well, this is not like to say, oh, Python can work with 10 gigabyte data sets in memory, etc. pp. This is more about having examples that you could basically verify and go through with pen and paper, but we implement the pen and paper simple examples, easily accessible with straightforward Python code, which nevertheless, when you say, well, here in this case, for example, starting with just two states of the economy, of the future economy, it is straightforward once you have mastered the formalism here to get to infinitely many states. So countably, I must say, in mathematical sense, infinitely many states. So that's the beauty of it. Once we have the basics mastered and have the intuition on our side, then to generalize things, to work with larger data sets, the more complex problems, typically is then the easy thing. A problem arises when you say, oh, well, that's too simple for me, and you skip maybe the intuitive part and like understanding the notions to the core of what they are about, and get started with like some complex stuff. And even back then, when I started my PhD work, I said, well, all these guys, they write about the most complex things, and I got lost when I got started with the research papers. And my PhD advisor said, well, get started with the most simple example you can come up with. Once you understand it there, then the other way around will be much easier to get then to the more complex state, rather than trying to master the complex state and getting back to the simple one. So this is what I have internalized since decades, I can say. And I try to convey this idea and to translate this approach here to the finance with Python class. We have different types of resources. I will go through them in detail when I do the demo. We have here the written materials, which are traditional standard. Then we have the videos, and of course we have the code. So basically all what we do is computational finance. Even if we do algorithmic trading, in that sense, it's something about computation and finance. And of course, code plays a role, the financial notion plays a role, and a bit of math play a role. And you get all the resources required in a consistent fashion on the Quant platform. More on that later on when I show it live on the Quant platform, because this is already important to get started in the first week. Tools and skills. This is another class we came up with since, for example, in algorithmic trading. Once you get to the stage where you say, well, I am now convinced after all the backtesting that I've done and strategy, a review and design, that this is the one that I want to deploy. But how do you deploy an algo trading strategy that might be supposed to run 24/7? Think FX, for example. It's hard to deploy this on your notebook when you might be even traveling or change like your location from your work to, let's say, back home or in a coffee shop. It's hardly possible. So we absolutely recommend to go with cloud deployment. And in this part here, tools and skills, we try to give you like all the tools that you need in order to do proper Python analytics, Python development and deployment up to the cloud level, where we say, well, this is then where you have automated deployment of a strategy, for example, in a professional environment. And here, one of my favorite quotes, I myself doing martial arts since I'm a kid, so since quite a while, and here from Yamamoto Musashi, The Book of Five Rings. In building a house, there's a problem of the selection of wood. So this is, for example, I would say, in analogy, the data and what we do with the data. But it is essential that the carpenter's aim be to carry equipment that will cut well, and when he has time to sharpen that equipment. So the equipment, the tools and skills, this is what we need. Not only the algorithms and the data and everything, we also need to know how to work with it. I mean, usually there are multiple ways to reach the same goal, but I think some of them might be more efficient and others less efficient. We try to provide you with tools that make you efficient. So in that sense, here you see the overview. The basics are mostly concerned with Python usage locally, Mac and Linux on the one hand side, and Windows on the other side, where we differentiate into two basic platform worlds there. Then to use Docker, I will have a quick demo for Docker as well. Again, differentiated Mac, Linux, and Windows. And then in the cloud, again, from a Mac, Linux environment or from a Windows environment. Ongoing, we cover basic Linux tools and some shell basics. Then in the development part, we cover Vim as a code editor that is available on every platform these days. Then a lightweight tool chain, Screen, Vim plus Q for editing, logging, debugging, doc test, unit test, Git version control, Python packaging, documentation, code hosting, and then it closes here with a case study. So here you will find for these topics 2 videos. And once you're able to run your Ubuntu environment, and this is the goal for Docker and cloud usage, then the rest is the same there. So it's quite a bit and maybe new for some of you. Others say, well, I've been working with Linux environments in the cloud since quite a while. I want to focus on the machine learning part. Perfectly fine. We have different skill sets, different backgrounds, and I think the way we deliver all the content makes it possible to focus on the more technical side, or maybe on the more financial side, or then maybe even on the machine learning and AI side in that sense. So in that regard, we have here Jupyter, which we will, over the course of the program, deploy in different environments alongside IPython and Vim on every infrastructure. Python, of course, is what we then run in the backend with all the packages, NumPy, pandas, and so forth. We will see how to do this in a Docker container, which is so helpful for deployment. So, for example, even if you work, let's say, on a Windows operating system, but you want to write your code for the cloud where you will run a Linux, a Ubuntu operating system, you can develop locally in a Docker container running Ubuntu on your Windows operating system and then deploy the code in the cloud, for example, maybe within a Docker container or directly on the cloud instance. I'm not saying that this is necessary and required for everything we do, but I think if you want to go a long way and if you want to deploy your trading strategies, this was my example from before, then from my point of view, there is no way around in this regard. So resources here, like the videos, you see a bunch of videos, and we present most of the codes in the form of GIST so that you can clone the GIST and can use the codes locally within a Docker container or in the cloud, so they can be reproduced and replicated, cloned into every environment. You will get access to all of this. So Python for Financial Data Science, that's the class that is based on my book, Python for Finance. And this is at the core of basically everything that is done these days in finance. So we cover the basics like data structures and data types, numerical computing with NumPy, data analysis with pandas, some OOP, stuff is covered. We have also additional videos that can be watched optionally. If you say, well, I need a little bit more on OOP, there are offers here as well. And data science, visualization, financial time series, input, output. Efficient in output is, I think, a neglected topic in general, but so important with what we do in finance, as well as the performance Python part. So both of these topics focus on efficiency and performance. Here, dealing with data, how can I implement Python input-output operations that are as efficient as my hardware that I have available allows, and performance Python, when I run algorithms on data, how can I make them as fast as possible? And math, of course, plays a role in finance. I think so. Some people and I myself believe that finance is nothing else than applied mathematics. So we have here mathematical tools, stochastics for simulation, statistics, and machine learning basics, as well as the special topic which you will encounter in so many different disguises, is dates and time. So that's the core class for everything else, I guess. Building on finance with Python, you here get then more exposure to larger data sets, more involved problems, let's say in statistics. For example, mean variance portfolio theory is covered as one of the examples, and much, much more. So it's also a larger class at the core based on the second edition, but you get access to an earlier draft version of the first 13 chapters here on the Quant platform, many videos, as well as all the Jupyter notebooks and all the codes that you need for this particular class. Python for Excel. We now enter the area where we say this is optional. So I myself am all but a heavy user of Excel. Here and there I use it, but mostly when I do it, it's related to some corporate training. And given the corporate trainings that we do and the emails that we get from corporates, of course, Excel is used still heavily in the industry. And I say my argument is basically that if you want to do Excel and want to do a little bit more involved stuff, why not combine the easy to customize Excel GUI capabilities with the analytics power of Python. And that's so easy these days based on Excel Wings, and it works to a large extent, not only on Windows, where it works, let's say, to 100%, if this is the benchmark that we want to set, it also works on Mac, for example, but not to 100% these days. So some things are possible, perfectly possible in a Mac environment, but others, like user-defined functions, are not possible as of now in the environment. So I myself have also a Windows machine with the latest and greatest updates and versions, etc. But on Windows, I can tell this is a fantastic combination. Working, for example, on the PowerShell. Here you see my Sublime editor. Sublime I use on both Mac and Windows, and if I have a local desktop Ubuntu, I use Sublime there as well. For example, here you see the VBA part and the Excel spreadsheet, and it's pretty straightforward using Excel Wings to combine the worlds, and it has become kind of a nice combination because you so easily build GUIs that you might even want to share or can share with others in your team or with colleagues or whoever you might want to share it. I don't necessarily need to have, let's say, Python know-how, but you can share the code with the user interface here with all batteries included in the form of Python with others and come up with powerful applications without having too much to worry about proper GUI development in this regard or a web interface. So for fast prototyping or internal applications, it's a pretty nice application. But again, I'm aware of the fact that not everybody is now prioritizing this topic maybe, so this is what we have as optional classes. But you can say this is the most important thing for me, I want to get started right away, feel free to do so. Python for databases. Of course, in the financial domain, when we deal with financial data, typically these days we face larger data sets. So coming from the old days, almost all financial theory has been based on end-of-day data. So end-of-day data means we have 250 data points where we just consider the closing prices. For a year, roughly 10 years, 2,500 data points. That's roughly the number that you see for a quarter of an hour for Apple tick stock prices. So 10 years worth end of day roughly represents a quarter of an hour tick data for a heavily traded stock such as Apple. This I think, yeah, illustrates that data has grown, financial data has grown, and I'm not talking about alternative data sets or unstructured data sources like news, etc. Just alone in the numerical domain, things have simply grown like in every other field. Therefore, we have come up with this class, which is called Python for Databases. And this is meant to make use of database technologies to efficiently manage larger financial data sets. The other motivation might be that you say, well, I'm working in a corporate environment, and we are anyways working with SQL or no SQL databases, so I want to know how this works. And we have there, after the introduction, motivation, like the area where we cover MySQL and SQLite as prominent popular SQL relational databases. In the NoSQL area, we have MongoDB and Python specific ones, which might be put into this category, PyTables, which is used, for example, by pandas under the hood intensively, SQL Alchemy, which provides you with a relational database abstraction layer where you might want to implement your code in Python without deciding from the outset which relational database to use later on. So you can maybe start developing with SQLite and later on shift to MySQL, or bcalls, which might be considered as a small, tiny Python competitor to KDB Plus in combination with Q. So for time series data, you might get, or larger data sets, columnar based, you might get an advantage by using bcalls. And then we also have a comparison with regard to performance, etc. So databases also something that is of importance to the one or the other, probably not to everybody. But I think an important topic overall, at least you know that you have access to the resources. We are not going to cover KDB. There's a question with regard to that. This is nothing that we at this stage cover. Although I see over and over that it has become more popular, and I think, or as far as I know at this point in time, the 30-bit version might be even come for free, so to say, for individual customers, while the 64-bit version is a licensed one. So in general, we focus on open source throughout. Excel, for example, is not open source, but if you have Excel, you can plug in Python. But all the packages that we use and that we present here are all open source and free to install. Resources, similar. There are 6 different sessions, videos plus resources. We show how to deploy it in the cloud. So first, you should have a little bit of experience of working with a cloud instance, because we said, well, what we do, for example, installing MySQL server and client infrastructure, etc., is best done in the cloud on a different machine to not mess up with your local machine. And you get also GIST resources, actually, which provide you with scripts and further background information with the Jupyter notebooks, etc., that are required to go through this class. Natural language processing. So, of course, not all the data in the financial domain is coming these days in structured numerical form. We also deal with unstructured data like news, or still so many people talk about Twitter as one example of social media network, which you might think of mining for, let's say, algo trading. But no matter what you do, even if you say, well, I have a quant finance textbook here, and I want to use my NLP skills and know how to parse my PDF and for example, create a graph of the topics that are covered there, that's possible with natural language processing. We have been working in the past, and that's publicly available with Dow Jones based on their DNA offering, where we expose quite a bit of material code and ready to apply NLP-oriented code there. Also with the data sets fixed, so you don't need necessarily a subscription there. And we are currently working with Dow Jones in the same area, but with regard to streaming news. So that's actually like the next frontier, that we are like in the numerical world, where we work first maybe with historical data, let's say for backtesting. Once we get started trading or pricing options, let's say in computational finance, There, of course, we need real-time prices where we access real-time data streams, but the same holds true for news streams as well. So we can stream news in the same way, and we need real-time mechanisms to come up with solutions there as well. And this is the next frontier where we're now working, for example, with Dow Jones, processing in the context of algorithmic trading, real-time news. Next frontier, different requirements, but with the Python ecosystem, fortunately, also possible. Resources, similar. We have the recordings. This is a shorter class, but it equips you, I guess, with the basic stuff that you need, which means codes, background, examples, and you get also, let's say, reusable snippets. And this is, from my experience, the most important thing. No matter which text, which area, you need over and over things like when you work with HTML, how to clean up an HTML document. And you don't want to re-implement this over and over. And there are a couple of basic routines, functions, methods that you might find in the typical packages. But from our experience, they bring you only that far. So you see here, a cleaner is this object, and we call the clean HTML function method there. But we have seen that maybe some other stuff might be helpful there as well. So maybe, let's say, some improved functionality is found and packaged for you, ready to use in this particular area. And of course, most of the data in our web-based world is unstructured these days, so we need NLP capabilities to get around there. Right, we now come to artificial intelligence in finance, one of my major focal areas over the last few years, not only algo trading, but AI in particular. It's getting more and more important. Just in the recent meetup I've mentioned already a few times, there was an interesting talk about how to use deep learning for what they called deep hatching. So neural networks that learn optimal hatching strategies for commodity derivatives, traded ones, non-traded ones, so dealing with physical assets. Very interesting approaches, and I think this has just started. So the train is still at the train station, and it's getting ready to take off there, but more to come, and I think the pipeline is filled up. There's also been a question with regard to how much AI is used in time series analysis. And of course, I mean, there are so many data sets, structured, unstructured, that can be put into a sequence form. So when the question is related to how much AI is used with regard to time series analysis, the first step is to say, well, AI with regard to sequences is one of the major fields. And when you think of it, a sequence is, for example, text. So text with regard to characters within a word and words within a sentence. This is all about sequence. So when we think in terms of neural networks and AI approaches, this is where recurrent neural networks come into play. And in this regard, time series are also sequences. We have a sequential structure. It's important whether B comes after A or A comes after B to some extent, at least. Maybe it's not the 100% of the story, but to some extent, this is what the sequence is all about. But we will see during the course, in particular of this class now, how we can apply AI approaches, and in particular, deep neural networks, recurrent neural networks, simple ones, but also the LSTM versions to time series data, and how we might be using that with regard to market prediction, let's say, or price level prediction, and what we might gain, let's say, compared to traditional multivariate linear or narrowly squares regression approach. So that's one of the focal points here in this area related to the question. Have a look at this class. This is the class that deals exactly with how AI can help you with financial time series. This is what we are going to focus on. And in that sense, we have the situation that this X, this is the input data in my world here, is growing rapidly. I talked already about it. We have historical structured numerical data, historical unstructured text-based data, let's say, just to have these two categories. We have the same in streaming fashion, and the markets, as we know, are nonlinear, complex, and changing. Financial history has been more normative in a sense that certain assumptions, axioms, etc., modeling approaches have led to some simple and elegant theories. Here, let's say the CAPM, mean variance portfolio theory, arbitrage pricing theory, risk factor investment, etc. pp. But we have, for most of these elegant theories, most of them have their origin, like, let's say, starting in the 50s earliest, but 60s, 70s, 80s. We have hardly any supporting empirical evidence, or it's, let's say, at best, it's mixed. So this is what I call brain-driven and the beauty myth in finance. We have all these elegant theories, but, well, the CAPM from the 60s is a nice theory, but who these days actually believes that the market movement is the only thing that influences the to expected returns for traded stocks out there? I mean, if that would be the case, then so many thousand analysts would be doing something that might be questionable out there, right? But now we're getting the chance in the times of big financial data, and that's the prerequisite. We have all the data, we have the tick data, we have more than we probably can digest or are happy to deal with, where we get back to positive economics as compared to normative ones. We say, well, let's have a look at the data and let's figure out what the relationships are, and then maybe we might draw our conclusions instead of the other way around. We have all these fantastic algorithms. I pick out again deep neural networks maybe that have proven so useful in other areas. Why not apply these approaches to the huge data sets that we have available? We might maybe get some good performance in predicting future market movements, but then people say, well, it's a black box. So a simple equation where I have a formal, final, we can say, mathematical proof, that's a nice thing. This is what every regulator, what my compliance department, what the model reviewers will understand. But here we indeed run in certain areas into compliance, legal issues, etc. pp. So when the Financial Services Authority or the SEC comes around the corner and says, well, why has the decision been made as it was made? And they say, well, because the model did it. But this might not be enough. This is an intensive discussion well beyond the financial domain, of course, and we won't lead that discussion here over and over, and others, experts, are dealing with that. There are approaches, but of course, there might be some new elements, new aspects that we need to deal with. But I rather go with the data-driven AI-first approach, which gives me some good approximation of the real world instead of the brain-driven and beauty myth in this regard. So this is actually what we have. And just to pick out one theory, expected utility maximization, which underlies so many of the other financial traditional theories that you find in the textbooks, it hasn't proven too useful in real world. There is basically no real empirical evidence. To the contrary, many experiments and empirical evidence suggest that expected utility maximization is simply the wrong model. But of course, the Netflixes, the Amazons in the world, the Spotifys, they have their deep neural network-based classification algorithms that can describe human behavior kind of well in their specific domain. So this is comparable from my point of view. Even if Netflix has, like, let's say, the algorithm, which is the best recommender engine in the world, they, in the end, might not really care to understand why this all works so well, and if this is a perfect representation of the human being and what's going on with a human being. It simply works. Maybe I'm a little bit too simplistic, but in the AI and finance class, we discussed this at least a little bit more in depth. Now coming to the core classes, and I said it already, many of those delegates that have signed up for the cohort that starts today have decided to go with the two core classes, which again makes me pretty happy. Not everybody has done so. This can also be done. This is just an offer from our end in the form of an upgrade later on that you say, well, now I've gone through all my materials of the one branch, so to say, I want to now try my hands on the other branch, for example. So there's still the option to do that. But let's get started with the Python for algorithmic trading part. Here you see the overview with the 16 blocks there. The first part is basically covered in the other areas like introduction, the environments, basic finance. And once we have mastered these blocks, we then assume that there is some basic fundamental knowledge from data science. So this is the financial data science class. This is finance with Python. This is also tools and skills to some extent. And here is financial data science. And building on top of these skills, we deal in algo trading, of course, with financial data. We do backtesting and prediction, but here we have some special problems like working with streaming data and maybe streaming visualization. We need to have some execution value, some online trading platform which allows us to execute our fantastic algorithms and algorithmic trading strategies that we have come up with. We cover Wonder, FXCM, Interactive Brokers, and Gemini in this area. And last but not least, in this core part here, automation of algorithmic trading. So it's nice maybe that you have, let's say, a toy example, which runs for an hour or two. But if you want to make real money out of it, probably you want to deploy this systematically. Let's say every day, Monday to Friday, from 9 a.m. GMT to 5 p.m. GMT, for example. And this is where we cover aspects of automation, deployment in the cloud. Then experience out of sample, backtesting. We have a practice module with regard to live trading, and also a longer one. So this builds on top of each other, where you are assumed to go through the three elements here in sequence. And last but not least, this is the necessary prerequisite and the final milestone to obtain the certificate itself. A final project to be delivered as a Jupyter notebook. Over here, a spell correction has jumped in. It's not Jupiter the planet, it's Jupyter with a Y. It's of course Jupyter notebook. This is a standalone executable Jupyter notebook, which should be accompanied by any data set that might be required. It's not about a live trading thing, so sometimes people ask me. Here at this stage, it's more like a small thesis that you are supposed to hand in, which has a title, an abstract, your name on it, and then some text explaining what you're going to do, what the goals are, your approaches, the methods, and then you present your stuff there. So this is sometimes of the question, but more details, of course, follow in this regard later on. This is a slide that I'm using basically unchanged since, I don't know, 2.5, 3 years. And still, this is my world of thinking in terms of Python for algorithmic trading. All get started with the right infrastructure, be it locally, be it in the container, be it in the cloud. Then financial data is what we need. Otherwise, everything will be sandbox. Strategy is put on top of that. We need to backtest our strategy code. Once we are through this cycle, so probably you will cycle here over and over until you are satisfied with what you see. You get further to the connecting side of things. This is now where you leave the local and historical world in general, where you say, now I need to work intensively with streaming data, I need to be able to, let's say, place orders. And all these things are important here. And then you can combine the world. Your offline algorithm will be transformed in what is called an online algorithm. You connect via the API, you place your orders, you track what's happening, you deal with stop loss, for example. And all these things embody then here the trading code. And last but not least, you say, well, with regard to automation, cloud deployment, real-time monitoring via socket communication might play a role, or logging, so that later on you can have a look. If something went well, you want to figure out why, or something went wrong, you want to figure out why. So all these elements are covered there. And these are our 7 levels of Python for algorithmic trading. The core class Python for computational finance. So this is now mostly concerned and related with regard to derivatives and in particular options pricing. and even more specifically, the market-based valuation of options and derivatives. This is what this class starts out with, like the market-based valuation, where we explore the differences between a theoretical valuation where you have a model, let's say Black-Scholes as a benchmark model, you put in a bunch of parameters and what comes out as the price of the option, versus you have a market of liquidly traded options which show prices, current equilibrium market prices. And the difference is that in a market-based valuation approach, we calibrate the model parameters so that we can replicate as good as possible the market observed prices. So that's like the starting point, that we have a good understanding of what this entails. Then we go through the theoretical building blocks here. We get started with the complete market models as a benchmark, like Black-Scholes Merton. We cover Cox-Ross Rubinstein binomial option pricing model. We go a little bit deeper with regard to the fundamental theorem of asset pricing, which we need for risk neutral valuation. Fourier pricing is our partner in the calibration procedure because it equips us with semi-analytical closed form formulas for European options, even in more complex, let's say, stochastic volatility jump diffusion models, which we then see in action here in the advanced column. American option pricing based on Monte Carlo simulation is an involved topic. This has its own block here. We then cover what is called in the blue book, derivatives analytics with Python, the general market model, which has special cases, Black-Scholes Merton, jump diffusion model by Merton, a stochastic volatility model by Heston, and the Bates model as a combination from 1996, plus stochastic short rate. So we have quite a bit of topics to cover here. And from a mathematical and formal point of view, this class is not probably for sure the most involved one, but this is simply due to the very topic that we are dealing with here. But the overall approach is a practical one. We present the theory, but the focus lies on the Python implementation. This is, I think, a good area here, Monte Carlo simulation. We present a couple of, let's say, numerical methods to discretize, let's say, stochastic volatility, stochastic differential equations, but the practical implementation, I think, is straightforward to apply. Calibration is the process that I mentioned before of finding parameters that allow a replication of market observed prices. Hedging, we do a review, and then the practice modules come in here as well. The major resource, of course, is the book here, Derivatives Analytics with Python, for which you find the current codes and updated codes. So it was originally based on Python 2.7 codes. Now there are Python 3.6 codes available on the GitHub repository, but all that is required is also provided on the Quant platform. This is what accompanies the book, but on the Quant platform, you get the same resources that are used in recordings, for example, as well. Here we have, let's say, the sister class, or a class that needs or should be studied alongside the core computational finance class. And this is with regard to our package, the open source package, DX Analytics, which allows quite a bit of derivatives analytics with regard to different topics there. We get started with a quick start. I show in a few minutes also the demo with regard to DX Analytics, a quick start. We cover framework and model simulation, European valuation, also American valuation is covered. You see it here. Derivatives portfolios is something we see here throughout, right? So the strength, or one of the major strengths of DX Analytics, is that it is able to model, value and risk manage complete portfolios of derivatives. And not only simple options, but also multi-risk derivatives, for example, with early exercise and quite a few twists on top of that. Fourier pricing is also here shown. American valuation, stochastic short rates introduced, derivatives portfolios again with a little bit more of a complex twist. And last but not least, you see after the multi-risk and calibration and hedging parts, we also cover complex portfolios. And when I speak here of complex portfolios, this might then go into the hundreds and might be composed of different types of derivatives. So usually the examples are not too huge given local restrictions. I mean, I have a machine, I don't know, 6 cores, 12 threads, 32 gigs of RAM. I can do a little bit, but still I'm limited with my local machine that I'm using here as compared to, let's say, a proper server like a workhorse deployed in a financial institution. So we have complex portfolios, but I think what I'm going to show there is not at the limit of what can be done with DX analytics. So this is a class that runs in parallel. It's a class in and of itself, but of course there are parallels and relationships with what we cover here in the core class. So resources available, of course, this is free on the web, it's open source, you get the documentation, here you see the Jupyter notebooks, and the class mostly basically is based on the Jupyter notebooks from the documentation with some reorderings and some adjustments being made. Here you see the overview of what DX Analytics can do. There is first the step where we do Monte Carlo simulation of cash flows, then optimal exercise policy for American options and risk neutral discounting. And this can be done for multiple risk factors at the same time for different derivatives, like a single risk factor derivatives, let's say European put option, here another European derivative, maybe 2 risk factors, an American derivative, 1 or multiple risk factors. We do position modeling and put the positions together into a portfolio for net payoffs. And the fundamental theorem of asset pricing, what we cover in risk neutral valuation, is what then holds everything together. We have 3 models for risk neutral discounting at our disposal: a constant short rate like in Black-Scholes-Merton, deterministic one with a term structure, or even a stochastic short rate that we can use also to model term structure as well as the stochastic behavior of short rates, which for shorter dated options it's usually not too relevant, but for longer dated one, and in particular, of course, let's say for rate sensitive ones, this might be an important aspect there. Here we have the other pyramid for this class: infrastructure, important financial data. This is what we need. We then have the models on top of that, the simulation for the models for year pricing, which is a necessary step for an efficient calibration. Once we have the calibrated model, we do the market valuation and hedging. So in parallel, we could always say, like related to the previous chart, this can be done for a single instrument, this can be done for a position, and it can be done for complete portfolios that are composed of multiple positions. So that's what this class is about. All practical twists, computational finance, as the name says. We want to compute things, and it's not a theoretical finance class in that sense, although the theory as a background is available in the book, and it's also presented in a concise manner during the exposition of the class, in particular the core class, Computational Finance. Now to the study plan. I've had already a few questions. How can I combine all this into a study plan? And given that we've decided to run the certificate programs in parallel, and many of you do both branches, so to say, we have come up with a replacement for the other study plans and have now an integrated study plan, for which I want to show you the schedule. You have, of course, access online to the study plan at any time. I've shared the link already. And here you see the overview for the 12 weeks, where we have on the left-hand side the core classes with the 2 branches. We have here financial data science, we have tools and skills, AI and finance, and the optional topic. So when I get started from the back here and go to the front, what I already declared optional during my overview is here Python for Excel. You see, I recommend getting started with it because I think this is a good thing to get started with. I commented already that Python for databases requires a little bit more background, so this should come a little bit later. Here I have put in the OOP recordings, when you say, well, what is covered here in OOP in the financial data science class might not be enough. This is an important topic. I get started earlier and have a little bit more exposure to that topic. Then Python for databases and NLP as the final optional one. Then we have, you see how important this has gotten. So when we included it into the program first, this was more or less here, that part, prediction-based trading. So this was originally where machine learning and deep learning was used, not exclusively, but with a focus there on this part. But now we have this whole class which gets started from the beginning. There we are not yet, in the very beginning, we are not yet dealing with algorithms. There, this is more general discussion of historical financial issues, of econometrics, issues like ordinary squares regression and what the major assumptions are, and maybe the shortfalls, etc. So you can get started right away, I guess, with that class, and it goes until the very end. Here, as you can see, I consider this, if you need to prioritize for the computational finance branch, optional. So the major example here is market prediction, which plays such a central role here in the algorithmic trading part. But overall, I think AI has already become, and will become even more so, such an important, prevalent topic in the financial domain that even if you say, well, I might not have like kind of a direct application of that, I should be like knowledgeable about what's going on there. And therefore, I will recommend, if you find the time, to follow along this class as well. If you say, well, I need to prioritize, time is a scarce resource, maybe for the computational finance branch, this is something that you might maybe want to do later on. Then we have the tools and skills part here. You see there is a little break in between, because once you have mastered that, this should give you a little bit of time to review and apply what you have been doing there. You have seen already the topics there, financial data science class. You have seen the topics as well. This goes basically also from the beginning until almost the very end of the 12 weeks. And coming now for the two major branches here, all should start with finance with Python. I consider these really core. So this is what I would expect at least that everybody knows after the first 3 weeks. So that's the very reason why we have come up with that. So, and to explain now, you see a bunch of things are highlighted in bold letters there. Finance with Python, or 1 or 2. This relates, and you will see this in a few minutes during my demo, to the videos, and down there in regular text, you see finance with Python, chapters 1 to 3. So this again means video 1, video 2, or module 1 and module 2. And this means in the written materials and documentation, first 3 chapters. And here accordingly, or 3 or 4, and chapters 4 to 6. The same holds true here. Data types and structures in the first week. This is the first video in that series, and we recommend that you read through the first 2 chapters, also presented here on the Quant platform. Maybe one comment here, PyAlgo is the documentation for the algorithmic trading class. Unfortunately, we cannot provide an electronic version due to licensing reasons on the Quant platform of derivatives analytics with Python. So here, when you see DAWP, this relates to the blue book. And the chapters 1 to 3, so it's basically the same thing. Here I changed the sequence a little bit for expositional purposes, but this is related to the book. You won't find the book itself, not in electronic, HTML or whatever fashion on the Quant platform for the mentioned reason. But overall, again, the bold text stands for the modules, the sessions, live and or recorded, depending on how you're going to do it and how it is implemented. The regular text underneath is with regard to what reading materials accompany or should be read for the classes. I would say it doesn't hurt if you read it afterwards. I would even say, well, that might be the better way to do it, to have first a look at the video and the code, and then maybe read a little bit about the background. But of course, feel free to read through it and then watch the videos. But I'd rather be the one seeing it first and then getting the background afterwards. But this is maybe a matter of taste or of your learning style, depending on simply what you prefer in this regard. You also see here we have two rows basically for computational finance, like market-based valuation, DX Quick Start. So this means indeed that we have two videos here. So computational finance in the core part has two modules, two sessions. So when you look on the Quant platform, you will find them. Currently they are numbered, but we might change the name shortly because we are just coming out of the life cycle there. So if there are questions with regard to the plan, feel free to ask them, for example, in the user forum, which I would recommend, because I'm pretty sure if you have the question, somebody else probably has a similar question. Or in the future, somebody might have the question, searching in the user forum, they might then find the answer. I think things that currently might be a little bit vague or unclear might be a little bit clearer when we go through the Quant platform and how it all works and fits together. So having said that, let's get started with the case studies and the demos. I try to keep them as short as I think is good for all of us, meaning that they are not meant now as a training session. What I intend to do here is just to whet your appetite, just to give you a feeling and an overview of what to expect in terms of content, in terms of presentation, in terms of style, etc. So again, this is not when I go through something now, you will see a bunch of lines of code and I will do maybe some stuff live rather quickly. But again, it's not meant that you should master that, or it's not meant as a training or instruction session. This is meant just to show and a little bit of a trailer, right? For the new movie, which might last for like the last Avengers movie for like 3 hours, and you get the 2 or 5 minute trailer. So in that sense, you should now consider what I'm going to do. But the Quant platform overview is also meant to additionally, beyond the resources we provide, give you some guidance how to navigate on the Quant platform. So it's the first topic, Quant platform. And let me dive and jump into it. So here you see also I have opened the PDF with the study plan. You have the link to that. This is in general updated on a weekly basis. This time I probably won't include the live sessions. You have live sessions separately, both via the weekly orientation emails and in particular via calendar invites, etc. So here you see things that maybe here and there, for whatever reason, we might change things a little bit, where on the go I decide it's better to do it the other way around. But it will be updated. You have access all the time to the latest version, which is supposed to be under the very same link, even if we update it. So you see here as of 12th May, yesterday I've updated it. So you always see where it is coming from. There's another question with regard to what is allowed with regard to the platforms. When you want to work with data and you have your own proprietary data platform, feel free to do so. We all the platforms that we use in the algo trading part, the computational finance class and core class, gets by with fixed data sets only that we provide you with, so no worries here. But if you want to work with, let's say, stream data or whatnot, we work with platforms that all have free paper trading accounts where you get access via the API to data, because this is at the core of what we teach there. But if you say, well, I have a Bloomberg subscription, I have a Refinitiv Icon subscription, feel free to do so, but we don't have it at the core of our program because we cannot expect everybody to have access to the same paid for subscription service. But of course, this will work for you. So here I'm logged into the Quant platform. You have received already a link to the Quant platform overview video. I want to just quickly go through the major points. On the left-hand side, you see navigation, but this navigation is, as it says here, for notebooks only. So before I jump into that part, let me quickly go through the tools here. We have the file manager, which allows you to navigate, you see here, similar to what we see there, through like the whole platform. Whole means your account on the platform. This might involve, as you see here for myself, a bunch of different folders. And if you wonder that yours looks different, yeah, this is different for every account. Some of the folders might exist in your account as well, others maybe not. So this is my account that I work as well. So I do stuff here which might not directly related, let's say, to the program. So I might have a folder that you won't see. Also, let's say some files that you see there. You see already the major difference in the file manager. I see files that are not shown on the left-hand side. Again, this is just related with regard to notebooks. And when I now go to FinPy, for example, you see in FinPy that we have here different notebooks. I can here click on FinPy as well. And we see notebooks as well, but only the notebooks. What you notice here is FinPy course PDF. This is not shown here because, again, this is just for notebooks. The file manager gives you access to everything. Via a right click in the file manager, you get access to a context menu depending on what you do. Like with this file, I can delete that file, rename it, create a copy. I can send like a whole folder to a zip file. I can download this file, create links, send it to, create a new folder, a new notebook, new file, export all files. So that's the context menu via right click here in the file manager. Of course, what you can do, you can open here with regard to FinPy, Jupyter Notebook, but I will come to that in a minute. Before I come to that, either opening it here or opening it there, I want to show you the written materials of Finance with Python. So recall, I open the file manager. This is for file navigation. But if you want to get started learning, recall Finance with Python. In the first 2 weeks, you click on Finance with Python, and what you see here is now the HTML version of the course materials. So it's a rather lengthy navigation on the left-hand side. This is structured in 6 chapters. Like here, I can navigate by clicking on that, static economy. Loading of this file, this is a rather lengthy HTML file as PDF, some 170 pages. This takes a bit because there are many LaTeX formula in there, and depending on the browser, etc., this might take a little while until it is properly loaded, and not only loaded as HTML, but until the LaTeX formulae are rendered. So on the left-hand side, you can navigate. And when I go, let's say here to uncertainty, for example, in chapter 2, you see here are the LaTeX formulas that I referenced before. And in that sense, this class, as you can see here, we introduce uncertainty with regard to cash flows. We present a mathematical representation here in the form of some linear algebra. And after that, we use NumPy to implement the linear algebra-based example. So we have financial notion plus a little bit of mathematics. Don't be afraid, it's not that much. As I said before, pen and paper is enough. And then we have the rather simplistic examples, but I said already, once you master the examples that way, they can be, well, like say, expanded, generalized to much more general and more involved settings. So getting the simple examples right and straight is the focus here. Later on, you can always get more complex. To get more complex, that's kind of like the easy thing. To boil it down to the core of the core, that's the hard part. So you have now here the assets in that sense. The assets in the sense of that's the full text that is presented. Here is the code, and you might wonder, oh, well, what about the code? Yves, do I need to copy this here out? And I would say, no, you can. You can even type it, which I would also recommend as a good exercise, but you have access basically to all the codes. Meaning that here now, we get back to our Jupyter notebooks on the left-hand side. Maybe I open here FinPy 1. This opens the first Jupyter notebook, chapter 1. And via the file manager, just to show you the alternative, I might open FinPy 02, which is the Jupyter notebook on which chapter 2 is based. So you now have here written materials and Jupyter notebooks. I've opened two, I've shown you two ways, and here you even see that this one is running, although I've opened it here from the file manager. That's the one thing. And in the file manager, you might have noticed it, here under FinPy, there's also a PDF. When I double click that or would download it, you have received the password. I can open here the PDF as well. So this is meant for people who might want to download it and read it, let's say on the iPad when they're sitting on a train or sitting on the airplane where there might not be any internet connection. I say, well, this is simply the way I want to access my materials. So you have the PDF version here as well. So this was recently updated, January 2019. So it's a rather recent version here as the PDF file of FinPy. But this is not yet the end of it. We have seen the written materials. I opened it here, Finance with Python. We have seen the code. This is stored in FinPy. We have opened already two Jupyter notebooks. I've shown you how to access the PDF file, namely from the file manager. You can also do here a right click on it and download it to your local machine and use it there. And last but not least, of course, we have the recordings here, Finance with Python. So the first three here are the written materials. And here we have Finance with Python. When I open this now, just having a look here. And you see here now the video section or the modules. We call this class with the modules. You see we have 4 modules, and when you recall the study plan we've got here, and it says Finance with Python 01 and 02. And on the Quant platform, this refers now to Finance with Python 01 and 02. You can play the videos from here, but if you want to access all the resources you see here, this is a link. The blue header is a link. When I click on Finance with Python 01, you see that more text appears, sometimes a little bit more text, sometimes text at all. And then also link to the slides that you can click on here, for example. These are the slides that have been used for this class. So they are hosted online. And you have here also additional Jupyter notebooks and also the slide deck here presented. But first and foremost, here is the video. I can click on this video from here and, for example, go forward, and that's the video for that class, which presents you with all the resources, some live coding, and you can play it here. Now I hear myself speaking in the background, so I mute that. And the video is now running, and you can go back and forth. You can, also, it's a good point that now jumps to my head. Sometimes people ask me, oh, well, I like to have the video and the codes alongside each other. You can log into 2 instances of the Quant platform and can have on the left-hand side of your screen, or if you have a double screen, on the left screen, you might have the video running. On the right screen, you might then have the codes open where you follow along. So that's perfectly possible. Can have multiple windows open. When you say, well, I want to have more real estate here, you can fold up also here the 2 of them, for example, to have almost full screen, or can get then even to full screen. So this all works here. You have the flexibility to access it as you like. So that's the video. And again, I show you here the resources. These might be additional notebooks. You see here, these are the ones that come by default with the class. And here we have the notebooks that might have been created during the live coding, etc. So you can double click on them as well. And as you can see, they open also immediately once you have double clicked. And this might give you access to the additional resources either created or provided with this particular module. So now you have seen what alone the Finance with Python class has to offer. So here's a little example with regard to a simple neural network approach. This is, as far as I remember, not in the core materials included, but here you get the additional stuff that is shown, used, created in the video, also directly accessible. So can close that again. Again, this is all here from Finance with Python 01, and this is exactly the area to which this here relates, Finance with Python 01, and Finance with Python chapters 1 to 3. This is here in the written materials. This will be chapter 1, Finance with Python, chapter 2, two-state economy, and chapter 3, three-state economy. These are the written materials, the documentation that are referenced in the study plan. And this holds true for all the other classes as well. So before I move on to the other class, there was one question with regard to why a Jupyter Notebook might not be running. And in 99% of the cases, this is due to somebody accessing the Quant platform and their specifically Jupyter Notebooks from behind a firewall. So here under help, so here I'm running, where do I have my, here is the FinPy session. That's the video. I was looking for the Jupyter Notebook. Here the Jupyter Notebook is running. For me, no problem. I open it. But if you are sitting behind a corporate firewall, and you can check that here via check ports, you see help, check ports, and what needs to be accessible, either you can speak to IT and say, well, PQP as a general domain should be freely accessible, or you say port 8000 of pqp.io should be accessible. So this would probably already do the trick. And you see here, I see a check. If you see, when you click on check ports, if you see a cross there, this indicates that this port is blocked in, I don't know, almost all the cases by a firewall, standard firewall settings. But in order to run the platform, we need this single one particular port. Otherwise, we could not provide from within this platform context the Jupyter Notebook environment. That's at least this one port needs to be accessible in order for this to run properly. So I said before that basically this whole structure can be found for the other classes as well. Let's pick one, for example, here, financial data science, the other big one. Everybody's supposed to get started right away. We have financial data science, and with some text and some overview. And here is module 1, data types and structures 01. So here in the study plan, you see data types and structures 01. And that's the first module here. So first module, I click on that. You see the video, you see a link to a slide deck. You see again, 2 Jupyter Notebooks here. Actually 3, sorry, it's 3 of them. Why Python, Python infrastructure, data structure. So this is where you get access to the resources there. Again, you might click on, let's say, the first one here to get started with, and you get access to the very first Jupyter Notebook here from, this is a short one, that's the reason why I opened it, the very first Jupyter Notebook here of this particular class. The reading materials are found here under Python for Finance. When you open that, this gives you access to the first 13 chapters of my second edition of Python for Finance, but it's an early draft. If you have the second edition anyways, let's say via Safari Online as an e-version or as a printed version, you can, instead of going here to the resources, you can perfectly pick up the printed edition, let's say, and can read through the text there. So this is from the first chapter up until statistics, including machine learning. This is a longer one. Here alone, this section is pretty long, has its own Jupyter notebook. And here is, for example, also the dates and times appendix, which goes in depth to the dates and times and the corners of the Python ecosystem, which deals with dates and times. Just to complete that, Task Manager shows you what is all running. You can shut down stuff from here. So I could shut down here, or I show you even if FimPy01 is closed here as a tab in the Task Manager, this is still shown as a running Jupyter notebook. So I've closed the tab, but it's still running. And here in the Task Manager, I can shut it down, or here in the notebook navigation, I can shut it down as well. So shutting it down here, you see immediately it shows here also the default value. Then we have editing capabilities. You can edit text here freely. Python codes, I think, would be a general use case. But if you fancy, also HTML and CSS files, if this is what you want to do there. Then we also provide access to a regular shell there. So where you have a Linux shell environment doing, for example, what I prefer, for example, doing file operations, copying around, moving stuff around. Typing this out here is, for me, in general, faster than using the file manager. But if you say, well, that's not my way of working, that's not a big deal. You don't have to. You have, for example, the file manager as well. But you also have, for example, access to Git version control. So if you say, well, I want to do some version control here with my project, I want to replicate, clone it, commit it, and whatever, with GitHub or GitLab or whatever, this is all possible. So we have, I think, the basic tools like Vim code editing as well. So when you say, I'm a Vim freak, I want to do code editing here on the shell, this all works. So almost full shell access. Then we have, it's my final point here, we have the user forum, and I strongly recommend that you make heavy use of that. You see here some user forums or boards, I must say, in the user forum are more active. Python for Algo training is the most active one with 238 topics there covered. And when you post something there, we get immediately notified by email. So there's no need to write an additional or an email in parallel. So to say, post it there, and not only one person is notified, multiples are. So your chances when posting a question are higher that you get a quick answer. And I'm pretty sure others benefit from the answers as well, or even a discussion. In some threads, there are also like other delegates that are discussing certain topics of interest. So feel free to use the user forum. It's what it's meant to be, a forum for all the users here in our training environment. Post it, we get notified, and we try our best to get back as fast as possible. Yeah, that's basically it with regard to the overview. You have access to all of what I've shown here. Feel free to explore the resources. Maybe you get started with finance with Python as shown in the plan, maybe with the written materials, maybe with the codes. You have the PDF here, the password protected one, which you can access. You have the modules, the 4 modules with the videos and the additional resources. All is there for you to get started immediately. The guidance is provided by the study plan here. If questions, again, feel free to best post it in the user forum. So Python with Docker is my next little demo. This was more like a walkthrough. And Python with Docker, I usually do just to say, well, not too many people have worked intensively with Docker, but it's a good tool and it's not too hard to get started with it. So what we show and what I use, what most people use, I guess, is maybe the first 2% of the valuable functionality, but this is already so valuable that you should try your best to do it. So here I'm having already prepared a command to start Docker, more details in the tools and skills class, which runs now a Docker container and which on my Windows machine on the Windows machine gives me now a Ubuntu-based environment. So I'm here now within Ubuntu in my Docker container, although I'm having a Mac OS operating system, or if you work on a Windows machine, you have also your Ubuntu environment where you have something like a root folder. And usually what you do, you get started with some update. This is what you know from all the other operating systems. First, the package index is updated, and second, the required updates and upgrades are implemented. So this is here because it's just a base installation, a quick thing, and now we are good to go. Good to go, for example, to install some helpful tools, let's say wget, bzip2, maybe screen, maybe htop, just a few. So all the free packages out there are now at your disposal. And I install here just a couple of packages. Again, not meant here as a training session, just to show you a few things. Now, I want to install Python. And what we in general use and recommend is the Miniconda installer. And there is this one landing page which provides me with the 64-bit Linux installer. So I'm here on a Mac OS X machine, but running in Ubuntu. I need to copy the Linux installer, and now I retrieve the Linux installer. This is, I don't know, some 50, 60 megs worth of data. I have retrieved it. I have it now in my root folder, and I can execute this now and install Python. It asks me now something. I say, yes, please go ahead. I read the licensing terms, I agree to the licensing terms. I'm getting asked for the default location of Python. I said that's fine, and the installation gets started. A few seconds later, I should be good to go. Here, prepend, I say yes, that's what I want to do. And I now have Python installed. Let me check. I type in Python. Does not work. There is no Python yet. But the only problem is that I need to restart my shell here, type bash. Now you see it says base. This now indicates that Conda has been installed, Conda Python. And when I now type Python, you see suddenly I have Python available, Python 3.7.3. I don't want to work here on the regular command line, therefore I exit this. Only thing I want to show you is like to install packages. So Conda is the package and environment manager. Conda install IPython is the improved Python shell, and NumPy maybe. And to speed things up, I use a meta package no MKL. Now it connects to the remote server, watches out what to install. I say, yeah, exactly, this is what I want to have. It's now downloading IPython as the shell. It's downloading NumPy without MKL, which is an Intel performance package. And when I now say, instead of Python, IPython, it starts my IPython shell. So I usually when I'm sitting here in front of my machine, I almost always have IPython open because I do calculations or just today I did some text processing, some sorting and getting rid of duplicates. So IPython for simple, smaller things is what I use. But we can make a little numerical example. I have installed NumPy. Now I have NumPy available. And that's already it, what I wanted to show you. Now I might be drawing with NumPy 20 random numbers. So that's basically it. I can access the previous output with the underscore, and I say times 10, for example, and work now in the environment. More details in the tools and skills class. I just wanted to show you, this was now, I don't know, how few minutes, less than 5 minutes. I have started a Docker container. I have done my home and housework there, cleanup and updating. I have installed Python. With the Python install, which I've activated, I have installed the IPython shell plus NumPy. And I can get started with my numerical operations there. So all less than 5 minutes of effort there. So don't be afraid of maybe new technologies. If you know Docker, I'm pretty sure you know about the benefits and maybe you even like or love it. If you haven't never seen it, don't be afraid of such new technologies you have seen once you have mastered the installation process, which is explained in detail for all platforms on the Docker page. You are able, as myself here, maybe a minute longer because you need to look up certain commands, but you're basically able to do the same stuff at the same speed with a little bit of exercise than I've been doing it. Don't be afraid of Python installation environments. I think after the course, you might not be black belt, but maybe blue or purple belt with regard to what we do here, Python development, deployment, etc. So I'm going to exit that. I'm going to exit my container. When I now look up, oh, I'm still here. Sorry, I wasn't still in the container. Now I'm back on my Mac. It says now Mac. PyCert was the name of the container. I can now look up my closed containers. Docker ps-a gives me old containers. And I say Docker remove 6769. This now removes the container that I've just created because it uses up disk space. And this was just an example. So I want to free the disk space and I remove my container and I'm done. So as simple and straightforward as that. And here, this is the page where you get access to all the installers for Python based on Conda and Miniconda. So now for both branches of certificate programs, efficient markets are important. Efficient market theory states basically that there is no value in analyzing historical data when you want to profit via trading from your analysis. To put it the other way around, in a regression ordinarily square sense, efficient markets say the best predictor for tomorrow's price is today's price. And well, why do all the systematic funds and the fundamental funds, etc., have armies of analysts and quants and developers and data engineers that try to figure something out? This is basically in the computational finance part, what we work with intensively, and in the algo trading part, what we work against. So hopefully after the coming upcoming demos, you will see why I have argued that way. So here I have already opened my 5 Jupyter notebooks. Efficient market first. And what I want to do with this Jupyter notebook. So here you see this I've taken from the AI in finance class. So this is something that is covered and discussed there intensively. I have a few imports. I use here scikit-learn with linear regression. So there are a few examples here. Linear regression, this is my sample data set. You see linear regression. For sure, it's not a good thing to approximate all these numbers. My R squared is 31%. So the explanatory power of my linear regression is pretty low. But I can go, here's an example from Jake Vanderplas's book, Python Data Science Handbook, basically where we do a higher degree fitting. And you see here with a higher degree fitting, we have here linear, then we have a quadratic fit and a cubic fit. So the original function has had a cubic element. So this is the highest monomial order that we need. And you see from cubic degree, fourth, fifth degree doesn't improve it. So R squared is almost 100%. Here, second degree is already 86%, and our linear was the worst here with 31. So that's not too good. And what we also discuss are topics like model validation. It's so important when we do prediction-based trading. Here, for example, consider this simple example where I do a splitting and do the split in a way that that I train the model on the first 60% of the data and then apply the model on the second 60%. So this is an example constructed with intention where you see our original data set, and we train the model on the first 60% and then apply it for prediction purposes. And oh my goodness, here we have a pretty high R squared on the first part. We might be confident in our wonderful model, but here the world looks completely different. And unfortunately, this is what we find in financial markets. We have a wonderful fitting, high values with regard to the important metrics, but when we try to apply it for prediction purposes, it miserably fails. And that's the reason why I've constructed this example that way. One way out in general, not with regard to time series without qualification, is that we do a random split. In order of a 60-40, we can do a 60-40, but in randomized fashion. And when we train the model on a random 60% of our complete data set, we see suddenly that the prediction is not too bad. So before we just trained it on the first 60%, prediction on the second part, and here we took from the 100%, but just a selection for training as well as prediction. Again, this is not meant as training, but I want to highlight here a few important topics with regard to the approaches. Validation curves here show that when we go over the different degrees of monomials, here are squared numbers. It doesn't work with a linear one. It doesn't work with a cubic one, but with a quadratic one. But from a cubic one, we get okay numbers. So random walks now. Here you see what I pointed out verbally before. In such a case, the best predictor of tomorrow's stock price in a least square sense is today's stock price. Now let us, with our ordinary least squares tool, try to get some support. And here there is some data, a standard data set that is used throughout. It's also the basic data set for Python for Finance, second edition. We calculate log returns, and now I do a little bit of plotting so that you see the data here with cufflinks, gives us the nice Hoover effects. These are the time series as a cross-asset data set, let's say Apple, Amazon, but Goldman and S&P 500 and gold ETF, etc. We can plot the histograms here as frequency distributions for the log returns, correlation. So these are just examples for visualization, right? With regard to the ordinary squares regression, I work with 7 lags of the prices. So here are the lags for Apple, and I implement ordinary squares regression. So, and what we see here already with regard to the numbers is that the most previous lag, so this is the today's price, given that we want to predict tomorrow's price, or is yesterday's price, given that we want to predict today's price, has all the weight in the regression here. So all the other lags don't play a role in predicting tomorrow's price. And when we visualize that stuff and we have a look here, you see the regression parameters visualized here basically tell the story that I have told you as an hypothesis. So in a least square sense, the best predictor for tomorrow's price is today's price. And you see here, it's basically responsible for 100% given our linear prediction approach using ordinary squares regression. All the others, like yesterday, the day before, another day before, like when we think in terms of lags, you see just lag 1, that's the one and only. Lag 7 here doesn't count. Lag 6 doesn't count. Lag 5, so we can go up until lag 17 or 70. The picture will be the same. It's just lag 1 that counts. And when we take the average, it's even more pronounced. So lag 1, almost 100%, 96.5, and all the others pretty close to 0. So for all numerical practicalities, you would say 1, and the rest is 0. So this is some indication, some support here, heuristically, anecdotically, if you like, for the efficient market hypothesis. And this is good for derivatives analytics, because in derivatives pricing, we work with market observed prices. And when we say, with regard to derivatives pricing, well, the market is always right. Markets are efficient. Then we say, well, this is what is given to us by the outside world and which we need to incorporate into our analysis. And this is where model calibration comes in. So my examples here have mostly been based, you see, based on stocks and ETFs and currency and gold, for example. But here it's now about options, but it's the same reasoning. If markets are efficient, we simply take, this is code that is explained in detail. If markets are efficient, we simply take the model as a flexible tool which we use to replicate what we see in the real world. When you think in terms of a stock, there's so many analysts that try to come up with a fair value, a price, a target for the Apple stock. But we as investors, we would look at the data, and the price is what the price is. And basically the market, if you believe in that, is right, and we see the price. And here we take this position that we say, well, the market is the right one. Our model needs to be calibrated, given the parameters that we have, in a way that we minimize the mean squared error, or here like the root mean squared error, so that we are able to replicate the option quotes as good as possible. And to this end, you see here we work with real options data. This is imported. We select here for the Euro stocks certain option quotes. So when we have a look at it, you see the pricing date is here 30th of September 2014. There are different strike prices. There are the call prices, the put prices. The maturity is relatively short. And we say, well, the prices that we see are the right ones. Our task here is to come up with model parameters which replicate the prices. And to this end, I implement here first a brute force calibration, where we try to minimize, to come up with the minimal mean squared error. You see here, the final number is the best, the lowest mean squared error we have seen so far. And it changes the 4 parameters that are the degrees of freedom. We are already below 1 here in terms of mean squared error. And the hope is that we get as close to 0 as possible. And what we get as the result here from the global optimization will be the input for the local optimization. So I can get started with it already. It waits until the other cell has finished, and it has now finished after 46 seconds. And now it takes the best result from the global brute force optimization and starts a local minimizer, which you see from the outset is able to improve upon the results. So we get some improvement with regards to the mean squared error. So when we now plot our results, comparing market prices with model prices, we see that the model prices here, the red dots, are more or less the same than the market price. And that's the big thing in the market-based valuation, that our model, first and foremost, is able to replicate market observed prices, because that's the idea which originates in efficient markets, that the market is always right. Here you see the differences are some €1 here. It's Euro stocks options, it's Euro denominated, and this is for the highest price, and this is the largest deviation that we see, minus 1.5, which is for the lowest price. This might be something that is too high. Other approaches discussed, for example, in my book, are that I can minimize, instead of the absolute mean squared error, I can also minimize relative differences. So this might then get a higher weight. So here we make use of efficient markets, that we say, well, option quotes are as they are. Let us back out the parameters which give us the option quotes, right? So model calibration. DX Analytics is a package with which you can do all this in a standardized, systematic fashion. I'm not showing here now the calibration, although this is shown as well. I just do a quick run through. Here you see the quick start. We import a few things. We have risk factor models, first the short rate. Then we work with market environments where we put in all the required parameters. We model geometric Brownian motion. We simulate a few paths. All is based on Monte Carlo simulation. We might have another factor here with a higher volatility, lower volatility, or even a different model. Then we model the objects to be valued. Let's say a European call option, European put option, American call, American put option. Here we can then price such an instrument, get estimates for delta, gamma, vega, theta, rho. And you see the beauty, it's an American option, and we get, like with the Black-Scholes Merton option pricing model, we get the Greeks. This is due to the numerics. Or we go here with the European ones, works in the same way. API is consistent throughout. There are special models like the Sabre stochastic volatility model, which is slightly different than the other ones typically used in DX analytics. We show how to model options portfolios. Here I introduced the notion of derivatives position. For a put, the quantity is 2 and some more, and for another position we have call, the quantity is 3. We have the risk factors, correlations, positions, valuation environment, and put all of that together in a derivatives portfolio. And when I spoke before of complex portfolios, this is just a portfolio consisting of 2 derivatives, but this could have easily 200 derivatives in there with different statistics like position delta, vega, and the sum of them. So can be used for risk management. There are also certain risk measures, like we can create risk reports, sensitivity factors on a portfolio level, also for risk management, typical what if and risk sensitivity analysis. All this explained in detail in the Computational Finance DX Analytics class. Again, this is the part, computational finance part, which makes use of efficient markets, where we say, well, market-based valuation means we take the market prices as given. These are our guidelines, and we adjust the models to best replicate what we observe in the markets. Let me close all these. In algorithmic trading, we say, well, maybe we can come up with some insights where we can generate market predictions that outperform passive benchmark investments, where we are now beyond pricing requirements. We say, well, we want to invest, we want to trade, and we want to create alpha. We want to get superior returns on a risk-adjusted basis. And this is where market prediction comes into play. And here I have a smaller notebook, a shortened one, again from the AI in Finance class, where I do some imports. I have here a data set from Rwanda, which is hosted, and which I read, and I say, well, let's assume we are the typical traders. We focus mostly on typical statistics and on bars, candlestick bars. And we derive here features for our models, the difference between close and open, between high and low, between high and open. We have volatility measures, simple moving averages, and momentum-based features that we feed into our models. And we do a lagging of all this, do a validation and a training split, do some normalization here in that sense. So here you see machine learning market prediction involves first and importantly data pre-processing. So typically before you apply an algorithm, there's a little bit of pre-processing of numbers crunching involved. And here it's the normalizer and lag function that I call, so that we end up with 210 relevant columns, or features as we call it. And when you have a look at how this roughly looks, we don't see everything, but this is a data frame, and we have all these lagged features like the momentum 2, lag 1, bop, bop, bop. So 210 columns are used as features here. What I use here for the prediction is a deep neural network. It's from scikit-learn with 2 hidden layers and 256 units per layer. And here I now do the fitting based on the train data. I train it on the first 60%, And afterwards, I take the remaining 40%. You recall my example with ordinarily scarce regression, which so miserably failed. But the approach here is the same. That's the reason why I highlighted it before. First 60% for learning, for training. Second 40%, second not really half, but yeah, the final 40% in a time sense, sequence sense, used for prediction. And this is what we do. So the model so far hasn't seen the 40% remaining. And we use the model now based on our 210 features and try to predict future performance, market direction in that sense. And what we get here based on our vectorized backtesting approach is the following. So the blue line is our reference. This is here 2018 in October, November, December, January, February, March, April. So this is intraday data. Maybe I was a little bit quick going over that. Here the data that we have is 30-minute bars, and it goes from beginning of 2018 to 2019. So 15,000 data rows, 15,456 data rows. And the test period is from October until end of March 2019, October 2018 until end. And what we see here is that with our approach, 210 features that we use here, the underlying, that's not a big surprise. I mean, the exchange rate simply has come down. It might go up afterwards, so who knows? It's a mean reverting quantity in principle. And here we have now the prediction. Under simplifying assumptions, no transaction costs or whatnot, we get a performance here of some plus 3 point something percent, and here we have a performance of minus 3%. So a relative outperformance of quite a bit. We have the numbers here, 96.7, so minus 3.3, plus 3.5, so we have some close to 7% outperformance given our approach. This is a simple one, a straightforward one, short example where you say, well, I have come up with the holy grail and I now want to trade such a strategy. Again, this is now the fight against efficient markets to say, well, I'm better than what the efficient market hypothesis might suggest, namely that there is no worth in like analyzing historical data, but we have done, at least in this particular example, single example, I must emphasize, we have done better. And now you might say, well, I want to deploy that. I want to run this with a platform. And that's my final demo here. It's with regard to the Wanda platform, which is in and of itself a self-contained example. I'm here importing a few things. I'm now connecting with my credentials to the Wanda API. And I might, in the meantime, also open my account there. Should be logged in. Yeah, I am. So let me go here so that I can show you what happens, because it's a real account and we want to do not some trading, but I place some orders. And with that data, this is a very simplistic example, but the strategy that we also have as an example in the PyAlgo class, where you say, well, a momentum strategy here, 6 bars going back, and we simply are concerned with the time series momentum. If the average of the most previous 6 bars is positive, we go long. If the average is negative, we go short. The hit ratio here is not it's not too good. You see we have more falses than trues. That sends 47.1%, not too promising. But if you get the right movements right, this might still yield a good result. And here we see the backtest. So it's a mixed performance for sure. It's just for a randomly chosen interval. We get some outperformance over a relatively short period of time there. And here you would say, oh, well, now let's get started trading. And I don't have like the code, which would have many more lines, which basically trades now this strategy. You see here the long and short positions visualized. But what I want to show you is you have done your work, your homework, you're convinced of your strategy, you're factored in topics like slippage and other elements, etc. In particular transaction costs. And then you say, now I want to trade. And here you see that's my account to which I'm connected. It says no open trades. You see here in the Yonder Trading web app, real-time Euro GBP 5-second and real-time Euro US dollar 5-second candlestick bars, Heikinashi, Japanese candlestick bars. And when I now here on the Yonder platform, as simple as that, I say API dot create order Euro US dollar 100 units. I get back the message from the API, and in my account, what we now have is a long position 100 units. I see real-time profit, profit in pips, profit in percent. So this is indeed now an order that we have placed via the API. So as simple as that, it's a single line of code here. API create order, and I can, for example, re-execute this line. So, or maybe I do simply, I re-execute this line. So it's another order placed, and what we see here, now we have another 100 units long there, right? It's a second order, you see the ticket, and we now have 200 long there. When I want to close it out, I would simply say units minus 100. Let me check quickly. And here we are left with one of our positions. And last but not least, I re-execute that line to close out the final position. So now I should have clean slate, and you see no open trades. I'm back where I came from, have lost a few cents maybe due to transaction costs. And via print transactions here, fixing the ID, I can now have a look at my most recent transactions. And you see here, this one trade made some 1 cent. It's just like small numbers for demo purposes, but it's real money. So small but real. And you see the final transactions here, the positions that have been traded, the order, so plus 100, plus 100, minus 100, minus 100, and here the P&L of this particular trade. This closed the first position, a little profit. This closed the second position, a little loss. As simple and as straightforward as that. Of course, you can do the same thing on a much, much larger scale with a much, much more sophisticated execution idea. So here in this part, algo trading, we try to beat efficient markets as a benchmark in the computational finance class. It's our tool via which we are able to calibrate models and to come up with prices that are in line with everything else relevant in the particular market we are dealing with. Don't need on anymore. So that much about the case studies and the demos. My final two topics, the user forum, I've shown it already. I recommend that you make heavy use. But one important point. First, maybe, I think that's clear, maybe you have a look at where to best place your question. That's, I think, a clear thing, a quick win, a low-hanging fruit. But then we have often the question, and that's not that we are like somehow religious about this topic. This is nothing about philosophy. It's simply about practical circumstances. People sometimes run into an issue and then they are like, I can fully relate to that and have full understanding. They are frustrated. Things don't work. And usually this ends up in a post on the user forum, which is like, dear team, I have done exactly the same way as was shown in the video and it doesn't work. So now I'm exaggerating, right? And believe me, we have a couple of these posts there. I have done exactly the same thing, but I get different results or it does not work. For us to provide any meaningful help, it's hard to work with such a general post. So typically when you have a technical question, I would assume that it's related to some code. The code does not do its job. And here I have copied the link as well as the major text from Stack Overflow. They have millions and millions of posts. We just have a couple of hundreds or thousands maybe there. And they know what they're talking about. Therefore, I didn't reinvent this whole thing. And this is a major post. It's called How to Create a Minimal, Complete and Verifiable Example. The second stage of my previous example is that Here you see the code snippet, and then you get like 3 lines of code, which do not work, but it's hard to tell what was happening before. And most of the things, from my experience, are related to some issues that happened, let's say 12, 15 lines before, when you import data or when you transform data and so forth. So therefore, please follow these lines. And I have had like a bunch of instances where people said, well, Eve, thanks for your hint with regard to this particular post. When I personally tried to come up with such a minimal, complete, and verifiable example, I stumbled across my problem because I tried to pin it down to the core of to the essence, to the gist, and suddenly it was so clear to me. So it's also helpful for yourself to come up with such a minimal, complete, and verifiable example. And again, it's not that we say, well, these are our strict guidelines. No, it's just like, if you want to get help quickly and profoundly, I think that's the best way to go about this issue. Try to be self-contained, minimal, complete, verifiable, so that we can simply copy out the code and check it on our own. Importance of practice, my final point. When you look at how people are trained in the professional and business worlds, you find a tendency to focus on knowledge at the expense of skills. We have tried to come up with a practical program which teaches skills. So even the tools and skills class has the skills expression in it. So I completely relate to that. I'm also a big fan of the book and of the findings there. So I believe the best approach will be to develop skills-based training programs. What we try. Training should focus on doing rather than on knowing. Of course, we cannot completely dismiss like doing exposition and providing you with content. But the major benefit you will gain from all this when you try to repeat it for your own, first by following step by step, by recalling it then and trying to do it on your own without any reference. So this is what we recommend. And yeah, don't despair. Like, no matter which area you study, here it is: music, dance, sports, competitive games, or anything else with objective measures of performance. And I think we can somehow put programming in that, because we have always the interpreter, which gives us like immediate feedback. You find that the top performers have devoted a tremendous amount of time in developing their abilities. In other words, there's no shortcut. You need to simply put in the effort. That's it. Put in the effort. Don't be afraid of putting in the effort. Don't be afraid of setbacks, of things that don't work. Put it in a verifiable way on the user forum. We help out. So that's not the point, I guess. Just do the work, and over time, you simply will develop and hone your skills. My final slide, it's from a previous certificate student, Elvis. And this is basically what, for me, would be a measure of success. Like a statement like that for you as a summary after the program. I liked watching your videos, thank you, but it's much more interesting and educational to actually build something on my own. And this is what we mean by practice, right? So look for some small things that you can do on the side where you apply the skills. Even when I bumped into issues, and that's like the hard part now, right? Beyond the comfort zone, I was able to fairly quickly find a solution which is a testament to the quality of the available documentation for the technologies that we are using. So give it a try, get started, get your hands dirty, get started with finance for Python with all the resources that you have available. Reach out via the user forum is the preferred way and the fastest one. And yeah, in that sense, I wish you a perfect start, a very good start into the certificate program or programs when you follow the 2 branches in the form of the package. I wish you happy Python coding, and I think Python is something that makes you happy, because typically you get good results, nice results rather quickly. And of course, all the success with Python for algo trading as well as for computational finance. In that sense, see you in the next session. Have a good start. Take care. Bye-bye.